Good morning. Welcome to Ellipses application problems. So the last 3 or 4 days we've worked on different types of ellipses, setting up equations, analyzing equations, all that good stuff. Today we're looking at word problems that lead us to utilizing those skills from the last 3 or 4 days to answer the questions. So for our first problem, we have a whispering room, which has an elliptical arched ceiling. So we have a floor somewhere, and over the top of that we have an elliptical arch of a ceiling. An ellipse has two foci, so let's draw those in. Alright, and at each focus is a person. And the sound waves are reflected by the ceiling and concentrated at the other focus, allowing people across the room to clearly hear what you said. Suppose such a gallery has a ceiling reaching 20 feet above a 5-foot high vertical wall. That means we're at 20 feet here. And that is if, let me correct this, we're 20 feet if we start our center at 0, 5, right? Because we're 5 feet above a vertical wall. So let's do that. So we're starting at 5 feet up for our center here, and then 20 feet above that center. And suppose the foci of the ellipse are 30 feet apart. So if these two things are 30 feet apart, that means it's 15 feet from the center to each vertex. What is the height of the ceiling above each whispering point? So we're trying to find that height. So first of all, we got to set up an equation for our ellipse. So we know what b equals. So b is 20. We know that c is 15. So we can use our equation, which was b squared equals a squared minus c squared, to figure out what a is. So 400 equals a squared minus 225. Add the 225 to both sides. We have 625 equals a squared. Square root both sides, and a would be 25. There we go. Alright, so now we can set up our equation for our ellipse here. So we have x minus 0 squared, because remember our vertex is 0, our center is 0, 5, over a squared, which is our 625, plus y minus k, or 5 squared over b squared, equals 1. Now our ellipse, or for our height here that we're trying to find, x would be equal to 15, and we're trying to solve for y, so we have 15 squared over 625 plus y minus 5 squared over 400 equals 1. 15 squared was 225. So we're doing 1 minus the 225 over 625. So we get y minus 5 squared over 400 equals 16 over 25. Let me move my paper. There we go. We can multiply both sides by 400. We have y minus 5 squared equals 256. The square root of that is 16. So y minus 5 equals 16 plus the 5, so y equals 21. So above the focus, we have 21 feet. Now we do have to remember that we are already assuming that this is 5 feet above the ground. So if you were to stand on the ground instead of 5 feet above the ground, we would have to say that the ceiling above the whispering point is 26 feet, is the height of the ceiling above the whispering point. All right, and there we go. All right, number 2, we have a satellite that can be put into elliptical orbit if need only, sometimes to be in high or low Earth orbit, thus avoiding the need for propulsion and navigating in low Earth orbit and the expense of launching into high Earth orbit. Suppose a satellite is in elliptical orbit with A being 4,420 and B being 4,416, and with the center of the Earth being at one of the foci of the ellipse. Assuming that the Earth has a radius of about 3,960 miles, find the lowest and highest altitude of the satellite above the Earth. So in order to do that one, we first have to figure out what C is. So we have to figure out what the focal length is here. Now we had our equation from earlier, b squared equals a squared minus c squared, or if we move things around a little bit, we can say c squared equals a squared minus b squared, which then means c squared equals 4,420 squared minus 4,116 squared, or 35,344. So c ends up being 188. So that means if we put the center of our ellipse at 0, 0, the center of the Earth is at 188, 0. So center of Earth, right, because the Earth is at one of our foci. So then we got to figure out the altitude. So how high does this thing actually go? So assuming that the, we're going to need a high and a low altitude. So with it being at that 188, so if we have our ellipse, this is our center here was at 0, 0. We have our Earth being here, so then the satellite can be either here or here. That's the furthest or the closest distance. Now the distance for the vertice to the center is a, right? So for our altitudes, we can have a minus the minus c, which is the focal length. But then we got to keep in mind that we also have the radius of the Earth, because we want to know what's the highest altitude of the satellite from Earth's surface. So what we're going to do with this 4,232, that's how many feet the satellite is from the center of the Earth. So if we subtract the radius of the Earth here, it's actually 272 miles above the Earth's surface. Now we also have the option that it's on the other side here, so 442, which is our A, plus the focal length gets us to 4,608. Again, we got to subtract the Earth's radius to that, from that, and we get 648 miles. So then this one right here is our minimum distance. That one right here is the maximum distance. And that is all for that problem. So let's see our next two problems here. So we have problem number 3. The main bales of a suspension bridge are 20 meters above the road at the towers and 4 meters above the road at the center. The road is 80 meters long. The vertical cables are spaced every 10 meters. The main cable hand in the shape of a parabola. Find the equation of the parabola, then determine how high the main cable is at 20 meters from the center. So there are two words that I said very, very clearly to make sure we understood that this problem is not asking for an ellipse, and that is parabola. So twice in there does it say parabola. So when you're reading these problems, make sure that when it gives you one of the conic sections to use, that you use that conic section. Now, we know that we have a bridge. We know that we have towers, that they're supporting cables, and that in the middle, that cable is 4 feet from the ground, and on the outside it's 20 feet above the ground. We also know that across the top, it is 80 feet from one tower to the other, and we're trying to write an equation for our parabola. So our center for the parabola here is going to be at the 0, 4, and then we got to find our a variable. So we have x squared equals 4a times y minus 4. Now we're going to plug in a value here. So vertical cables are spaced every 10 meters. That's not going to help us a whole lot, but we know what this point is. That point right there is going to be 40, 20. So we can plug that in. We have 40 squared equals 4 times a minus 20 minus 4. So we have 40 squared equals 4a times 16. If we solve for a ends up being 25. So our equation here is x squared equals 100 times y minus 4. We're going to plug in the 20 to solve for the height, so the 20 goes in for x. And if we solve that for y ends up being 8 meters. So the cable at 20 meters from the center is 8 meters tall. All right, let's keep going to problem number 4. The outer door of an airplane hangar is